All right, y'all, this is part 3 of 10-3 or 10-2, graphing cube root functions. The graph of cube root function m is shown. Okay, here it is. Beautiful. Compare the average rate of change of m to the average rate of change of h of x equals the cube root of 1/4 of x over the interval x equals 0 to x equals 8. A lot going on there. So it looks like we have two separate graphs here, right? Or two separate functions. You have function m, which we have a graph of, right? And then I'm going to make a line here, separate the two. And then we have function h. And what are we doing? We're comparing the average rates of change. Let's think about what an average rate of change is. When we talked about rates of change, a rate is something like miles per hour, where you have different units in the numerator and the denominator. Rates of change on a graph that has an x and a y axis, that rate of change is the change in y over the change in x, what you know of as slope. So this average rate of change, that is the slope. Now, as you can see, this isn't a line, right? This isn't a line. So the rate of change between like this point and this point would be, you know, a relatively shallow line, but the rate of change between like this point here on the graph and this point here would be a really steep line. So the rate of change is changing depending on what 2 points you select on this graph, right? You need 2 points to show the slope. So what we're going to do is we're going to find the average rate of change. We've talked about this before, but the average rate of change means I don't care how those rates of change are changing depending on what 2 points you choose. I'm only going to pick the points where x is 0 and x is 8. So when x is 0, I get a point here at 0, 0. When x is 8, I get a point that looks like it's at 8, 8. I'm going to pretend that there's just a line through here, and I'm going to find the slope of that. Well, what is the slope of that? 0, 0, and 8, 8. Well, remember this is rise. You rise 8 over run. You run 8. So the slope of function m, the rate of change, or average, let's do average rate of change for m is equal to 8 over 8, which is equal to 1. So the slope, if you drew a line between these 2 points on the graph, would be 1. For function h, we don't have a graph, but we can still find the average rate of change. What we need are just 2 points, right? Similar to what we just did here. I'm going to find 2 points, and those points are going to be when x equals 0 and when x equals 8. So I'm going to substitute 0 into this function. That's easy. 1/4 of 0, 0. The cube root of 0 is 0. Sweet. So these both have a point at 0, 0. But when I substitute 8 in for x, I have to take 1/4 of 8. I have to take 1/4 of 8 and I get 2. So I have to take the cube root of 2. Well, what's the cube root of 2? We need a number times itself that's equal to 2. Well, 1 times 1 times 1 is 1. So whatever the output is doesn't have to be greater than 1. Doesn't this number have to be greater than 1? So that it's the cube root of 2 has to be a number greater than 1, so that that number times itself is going to equal that 2 that was inside the radicand. So that means the change in y, here are our y values, 0 and 1. The change in y, the average rate of change, is going to be equal to a number greater than 1 over, how far is it from 0 to 8? That's 8. So a number greater than 1 over 8. But, oh, I should say it's less than 2. So how is this slope comparing to this slope? Well, this slope is going to be, how much greater than 1? If you look at this number, it can't be 2. because 2 cubed would equal 8. So this number must have been in between 1 and 8. So this slope for function h must be smaller than this slope for function m. So the average rate of change for h is greater than the average rate of change for m. All we're being asked to do is to compare them, so we don't even need to figure out what their values are, and we have the solution here. All right, everybody, that's the end of part 3 for 10-2. Keep up the awesome work.